November 8, 1942, marked a perilous day high above the Gilbert Islands in the vast expanse of the Pacific Theater. Lieutenant Robert Scott, skillfully maneuvering his P-40 Warhawk, executed a sharp bank to the left as a deadly stream of tracer rounds from an agile Japanese Zero narrowly missed his aircraft's canopy. His thumb instinctively hovered over the trigger of his armament, eager to unleash the formidable power of 6 Browning 50 caliber machine guns, the United States' most potent airborne offensive weapon, all primed and ready for action. With a determined squeeze of the trigger, however, he was met with a series of disheartening clicks, signaling a complete and simultaneous failure of all 6 weapons. Observing Scott's sudden silence, the Zero pilot seized the opportune moment, turning with predatory intent for the fatal blow. Scott, in a desperate bid for survival, plunged his P-40 into a steep dive, pushing the aircraft to its absolute operational limits, ultimately finding sanctuary within the protective embrace of cloud cover. Upon his return to Henderson Field, his heart still hammering from the adrenaline of the narrow escape, his aircraft bore the telltale scars of numerous bullet holes. "The guns jammed," he reported to his commanding officer, his voice tinged with frustration and disbelief. "Every single one, within the very first burst." This alarming incident was far from an isolated occurrence. Indeed, across the breadth of the Pacific, from the embattled shores of Guadalcanal to the dense jungles of New Guinea, American aviators were consistently reporting an unacceptably high rate of catastrophic failures with their .50 caliber Browning M2 machine guns. The statistical data paint a grim picture, revealing a deeply troubling trend. Throughout the aerial engagements of 1942, the M2 Browning machine guns suffered a jamming rate ranging from 18 to 22%. This meant that nearly 1 in every 5 weapons could be expected to malfunction at the most critical junctures of combat. On aircraft equipped with 6 or 8 such guns, the probability of at least 1 weapon jamming during any given engagement soared to an alarming 75%. The underlying issue, it was widely understood, did not stem from any inherent flaw in the gun's foundational design. John Browning, a true visionary, had crafted a masterpiece before his passing in 1926. Rather, the crux of the problem lay in the intricate mechanics of headspace and timing. The precise, millisecond-perfect synchronization required between the bolt, S complete closure, and the firing pin, R subsequent strike. When these critical parameters were incorrectly calibrated, the weapon would either fail to discharge entirely, or far more catastrophically, detonate a round while the bolt was still partially open. Such an event would not only irrevocably damage the weapon itself, but also posed a significant risk of compromising the structural integrity of the aircraft, potentially leading to its loss. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please write a comment about where you are from and what you think about the video topic. Each M2 machine gun necessitated a meticulous manual adjustment of both headspace and timing after every barrel change or period of intensive usage. Field armorers were ostensibly equipped with specialized gauges and instructed to adhere to stringent procedural guidelines. However, under the unrelenting duress of combat conditions, amidst the stifling tropical heat, contending with battle damage, and utilizing worn or fatigued components, these delicate adjustments devolved into a perilous gamble. Improperly set timing could precipitate 3 distinct and disastrous failure modes: Premature timing would cause rounds to fire before the bolt had fully closed, resulting in case ruptures that inevitably jammed the action. Conversely, if the firing pin struck after the bolt had already begun its opening cycle, dangerous pressure spikes would ensue, and excessive headspace permitted the cartridge cases to separate, thereby jamming the chamber. The cumulative consequence of these systemic failures was American pilots confronting enemy fighters with weapons that unpredictably ceased to function, and bomber crews over Germany watching helplessly as their vital defensive .50 caliber guns fell silent just as menacing Luftwaffe fighters closed in for the attack. What remained entirely unknown, what nobody could possibly foresee as Lieutenant Scott grappled with yet another brush with death, was that the ultimate resolution to this profound crisis had in fact been conceived a decade prior by a remarkably unconventional gunsmith at Springfield Armory. His name was Samuel Green, and his daring, almost suicidal proof-testing methodology was poised to rescue the entire .50 caliber program from the brink of abandonment. The formidable Browning .50 caliber M2 machine gun commenced its developmental journey in 1918, nearing the twilight of the Great War. John Moses Browning, widely celebrated as America's preeminent firearms designer, ingeniously scaled up his highly successful .30 caliber M1917 design to accommodate the colossal .50 BMG Browning machine gun cartridge. The cartridge itself was a marvel of destructive power, measuring an impressive 5 inches in length. It propelled a hefty 700-grain bullet at an astonishing velocity of 2,900 feet per second. This immense power enabled it to pierce aircraft armor at distances of up to 1,500 yards and effectively incapacitate armored vehicles. It was, in essence, the quintessential anti-aircraft and anti-materiel weapon. Yet, when the inaugural production model, designated the M1921, entered service in 1921, it proved to be an intricate nightmare of mechanical complexity. The M1921 existed in no fewer than 7 distinct configurations: water-cooled, air-cooled, aircraft-mounted, tank-mounted, anti-aircraft, flexible, and fixed. Each variant demanded unique parts, specialized maintenance protocols, and different timing adjustments. Most critically, the vital timing and headspace parameters required manual adjustment by armorers every single time the barrel was swapped out, an event that occurred with disconcerting frequency under combat conditions. The prescribed procedure entailed a painstaking sequence. First, installing a go gauge to establish the minimum headspace, followed by a no-go gauge to define the maximum headspace, then precisely adjusting the barrel lock nut in infinitesimal increments, and finally setting the timing with a separate gauge while manually cycling the action. This was all to be concluded by test firing and subsequent readjustment should any malfunctions manifest. In a meticulously equipped workshop with ample time and the right tools, a seasoned expert armorer could accomplish this intricate procedure within a mere 20 minutes. However, in the unforgiving crucible of combat, whether on the rolling deck of an aircraft carrier, at a hastily established forward airfield under the constant threat of artillery bombardment, or amidst the rain-soaked oppressive jungles of the Pacific, this vital adjustment process transformed into an unending source of critical problems. The ramifications were invariably lethal. A comprehensive 1925 Army Ordnance Department study, which rigorously examined 500 M1921 machine guns already in active service, yielded damning conclusions. A staggering 47% of the weapons exhibited incorrect headspace settings. and an even higher 61% suffered from incorrect timing. The average interval between failures was a mere 840 rounds, equating to less than 2 minutes of sustained suppressive fire. Furthermore, an alarming 23% of barrel changes resulted in weapons that were utterly incapable of firing. The unanimous expert consensus was unequivocally clear. The M1921 was simply too complex and temperamental for effective deployment in the field. Major General C.C. Williams, then the esteemed Chief of Army Ordnance, articulated his profound concerns in 1928, stating, "The current .50 caliber machine gun represents the absolute zenith of what can be achieved with manual timing adjustment. Unless a fundamental redesign fundamentally eliminates the necessity for field timing, this weapon will perpetually remain unreliable under combat conditions." The Army, facing such dire pronouncements, seriously contemplated abandoning the .50 caliber program altogether. Some influential officers even championed the adoption of 20mm cannons as an alternative, citing their fewer numbers required, simpler maintenance regimens, and the proven efficacy of European technology. However, a significant drawback plagued these cannons: their comparatively low rate of fire. The .50 caliber M1921 could unleash between 450 and 600 rounds per minute, whereas most 20mm cannons fired a paltry 60 to 120 rounds per minute. In the dynamic realm of aerial combat, where fleeting targets materialized and vanished within mere seconds, the sheer volume of suppressive fire held as much strategic importance as the individual hitting power of each round. The Army thus found itself ensnared in an agonizing dilemma: persist with an inherently unreliable weapon or pivot to an alternative that possessed undeniably inadequate firepower. Then, in 1926, John Browning, the guiding genius behind the .50 caliber program, passed away, leaving the project adrift without its visionary leader. Development subsequently stalled. Various engineers proffered a multitude of proposed modifications, ranging from more robust springs and revised bolt designs to different barrel lock mechanisms. Yet none managed to resolve the core intractable problem. The gun stubbornly demanded expert adjustment that was virtually impossible to execute under the chaotic pressures of combat. By 1930, the U.S. military had already committed a substantial $2.3 million to .50 caliber development, an amount equivalent to a staggering $42 million in today's currency, with precious little tangible progress to show for it. The M1921 languished in limited service, but military strategists were rapidly losing faith in its potential. At Springfield Armory in Massachusetts, the Army's premier facility for small arms development, a dedicated but dwindling team persevered in their efforts to implement improvements. Their budget was slashed, their project priority downgraded, and the majority of the elite engineers were unceremoniously reassigned to other, ostensibly more pressing, endeavors. It was at this critical juncture that Samuel Green stepped forward to assume leadership. Samuel Green assumed leadership. Mr. Green was not, by any stretch of the imagination, a firearms designer in the conventional sense. Instead, he distinguished himself as a mechanical engineer whose primary expertise lay in the intricate domains of manufacturing processes and rigorous quality control. His professional background was deeply rooted in the precision machining industry, a field quite distinct from the conceptualization and development of weaponry. The United States Army had in fact assigned him to the challenging .50 caliber program, largely because no other engineer expressed interest. It was widely perceived as a stagnant, career path, an assignment destined for professional oblivion. What the Army failed to comprehend, however, was that Green's profound proficiency in manufacturing was precisely the crucial element the M2 Browning machine gun required. The fundamental flaw, as Green intuitively understood, was not in the weapon's inherent design, but rather in the impracticality of its proper maintenance in demanding field conditions. Consequently, Green initiated his inquiry by posing a radical question that had eluded all his predecessors. What if the necessity for any field adjustment could be entirely eliminated? Samuel Green, born in 1891 in the industrial heartland of Worcester, Massachusetts, was far from the archetypal weapons genius. His formative years were spent amidst the churning machinery of American manufacturing, where his father operated a modest machine shop specializing in textile equipment. By the tender age of 14, Green was already an active participant on the shop floor, diligently learning to decipher complex blueprints, skillfully operate lathes, and meticulously maintain precision tolerances. His pursuit of higher education led him to Worcester Polytechnic Institute, where he enrolled on a partial scholarship, dedicating his studies to mechanical engineering. His scholarly endeavor culminated in a thesis focused on reducing manufacturing variation in mass-produced components, a topic whose perceived monotony was such that his advisor reportedly struggled to stay awake during the defense. Yet Green's seminal contribution was nothing short of revolutionary for its era. His insight posited that exceedingly tight manufacturing tolerances could completely obviate the need for manual adjustment. If components were fabricated with sufficient exactitude, they would function flawlessly upon assembly, necessitating no subsequent fiddling by skilled technicians. This was 1913, a time when the assembly line itself was barely a decade old, and most manufacturers still relied on workers to hand-fit individual parts. Green's pioneering ideas were, at the time, widely deemed unfeasible, prohibitively expensive, and overly onerous to achieve with the existing industrial machinery. Following his graduation, Green embarked on a career traversing various manufacturing companies, steadily cultivating a reputation as the individual capable of resolving seemingly intractable tolerance problems. With the outbreak of World War I, he was enlisted by Springfield Armory, where his expertise was crucial in helping to enhance rifle production. He remained at the Armory after the cessation of hostilities, channeling his efforts into refining the production methods for the M19903 Springfield rifle, the M1911 pistol, and an array of machine guns. By 1930, at the age of 40, he stood as a distinguished senior engineer, possessing an unblemished professional history, but, notably, enjoying scant public acknowledgment for his contributions. His meticulous work consistently facilitated the widespread production of other people's designs, yet the manufacturing guy remained largely unremembered. Thus, when the .50 caliber program teetered on the verge of imminent termination, it was Samuel Green who voluntarily offered to assume command. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. His superior expressed considerable apprehension. Sam, he began, this particular program has thwarted the efforts of some of our most eminent designers. Even Browning himself was unable to resolve the complex timing problem before his passing. Green, however, countered with a succinct and profound observation. That is because they are approaching it as a design problem. It is, in reality, a manufacturing problem. He dedicated a quarter of a year to meticulously analyzing every failure report, every field complaint, and every documented instance of operational deficiency. He interrogated armorers, seeking their first-hand accounts, and personally witnessed their attempts to set headspace and timing within simulated combat environments. He expended thousands of rounds through M1921 machine guns, intentionally incorporating worn parts, damaged components, and improper adjustments to ascertain precisely what failed and why. His ultimate conclusion was damning. The M1921's timing adjustment mechanism was exceedingly delicate. A minute alteration of the timing nut, amounting to less than a single millimeter of movement, constituted the critical difference between optimal performance and a disastrous breakdown. It became unequivocally clear that no armorer could reliably attain such exacting precision under the chaotic duress of combat conditions. The apparent solution emerged with startling clarity. Reconfigure the gun so that its timing was preset at the factory, thereby negating any requirement for subsequent field adjustment. However, this presented a formidable challenge. Fixed timing necessitated that the weapon function with unwavering functionality across every barrel, in every conceivable environmental condition, and despite every manufacturing variation. The level of unparalleled exactitude required in the tolerances surpassed anything Springfield Armory had ever successfully achieved. Green's superior was forthright in his assessment. "Sam," he stated plainly, "what you are advocating for demands manufacturing precision that exceeds our present capabilities. We simply cannot maintain such stringent specifications across thousands of guns." Undaunted, Green responded, "Then we will elevate our production standards, because there is no other viable alternative." What transpired next marked the pivotal juncture where Green's unorthodox strategies and his unflinching resolve to risk everything permanently altered the trajectory of weapons history. Within the confines of the test bunker at Springfield Armory, on March 15, 1932, Samuel Green stood beside the inaugural prototype of what would ultimately become the M2 Browning. The comprehensive redesign process had spanned 18 months, during which every critical dimension had been meticulously optimized. The barrel lock mechanism, in particular, had been completely re-engineered to obviate any need for timing adjustment. The headspace was now calibrated at the factory using exacting instruments accurate to 0.001 inches, a standard 10 times more precise than any previously implemented. Yet Green understood that precision manufacturing alone was insufficient. He needed to demonstrate the weapon's unwavering functionality under the most extreme operational scenarios imaginable. His audacious solution was both remarkably simple and profoundly insane. Green had devised what he termed a proof round, especially engineered 50 BMG cartridge, loaded with 30% more propellant than standard military ammunition. Consequently, the generated chamber pressure exceeded 70,000 Haust psi, a figure well beyond the gun's inherent design limits. If any component possessed even the slightest manufacturing flaw, if any tolerance was off by even a fraction of a millimeter, the weapon was guaranteed to catastrophically fail. At 70,000 psi, such a failure meant the receiver itself would rupture, ejecting lethal fragments in all directions at supersonic velocities. Anyone unprotected within a 20-foot radius faced instant fatality. The test bunker, while designed to shield observers from the hazards of normal weapons testing, was demonstrably insufficiently reinforced to contain the explosive detonation of a .50 caliber machine gun. Green's subordinate, a junior ordnance officer named James Patterson, was visibly appalled upon seeing the proof rounds. "Dr. Green," he exclaimed, "this is unhinged. If that gun explodes, then we'll merely confirm the inadequacy of our manufacturing tolerances." Green, ever stoic, retorted, "You could be killed." Patterson, still aghast, responded, "Then another individual will need to finish the project." Patterson promptly conveyed Green's perilous plan to his superior officer, the armory commander, Colonel Howard. Colonel Howard materialized at the test bunker within moments, his presence signaling the grave urgency of the situation. Dr. Green found himself at the test bunker within moments, a palpable tension filling the air. Colonel Howard, his superior, addressed him directly, acknowledging Green's audacious proposal to subject his prototype to testing, with ammunition intentionally overloaded. "Yes, sir," Green affirmed, his voice steady. "Proof testing remains a fundamental and necessary procedure." However, Howard's apprehension was clear, stating that a 30% overload transcended mere testing, bordering on outright recklessness. He warned of dire consequences, suggesting that even the fortified bunker might not withstand an explosive failure of the weapon. Undeterred, Dr. Green articulated his unwavering conviction. If the weapon could not endure such extreme proof loads, it was unequivocally unfit for active combat duty. He emphasized the profound responsibility of ensuring the weapon's absolute reliability, knowing that soldiers' very lives would depend on its flawless performance in the field. Howard proposed a more cautious, graduated approach, beginning with a 10% overload, then incrementally increasing it to 15%. Yet Green firmly rejected this suggestion, explaining that such phased testing would fail to expose critical manufacturing defects that only the most severe, worst-case conditions could reveal. He acknowledged the deviation from standard safety protocols, but respectfully countered that the existing M1921 model regrettably caused American casualties due to its operational failures in combat. Green declared he would not sanction the M2 design for mass production until he had personally verified its resilience under circumstances far exceeding any conceivable battlefield scenario. Colonel Howard's gaze lingered on Green for a prolonged contemplative moment, the weight of the decision evident. He voiced a grim concern, stating that if Green were to perish during this endeavor, he himself would appear foolish for having granted authorization. Green, his response was swift and resolute. "Then I'd better not die, sir." With a heavy sigh, Howard ultimately signed the necessary authorization. Dr. Green then proceeded to meticulously load 10 specialized proof rounds, each a potential instrument of the weapon's destruction, into the magazine. As he chambered the initial round, his hands remained remarkably steady, a testament to his meticulous calculations. The intricate mathematical models had unequivocally predicted the weapon's survival, and now that theoretical certainty faced its ultimate practical validation. With a deep breath, Green deliberately engaged the trigger mechanism. We invite you to stay with us and watch the thrilling conclusion of this video. Your like and subscription would be greatly appreciated. Please also leave a comment below, letting us know where you are from and what your thoughts are on the critical importance of military equipment reliability. The date was March 15, 1932. At precisely 2:47 p.m., within the confines of the Springfield Armory Test Range. The first proof round detonated with an ear-splitting report, a sharp, metallic crack that reverberated deafeningly across the entire facility. The recoil generated was extraordinarily violent, causing the sturdy test mount to shudder perceptibly. Yet, against all odds, the gun did not explode. The receiver, the core structural component, held firm, and the barrel remained entirely intact. Green, with unwavering focus, chambered the second round and fired. The weapon cycled flawlessly. He continued, firing the third, fourth, and fifth rounds, each discharge confirming its remarkable durability. By the time the 10th and final proof round was fired, Patterson, initially observing from the supposed safety of the bunker wall, had abandoned his sheltered position. He now stood directly beside Green, captivated and utterly mesmerized by the gun's astonishing performance. "It's holding," Patterson whispered, a sense of awe in his voice. Green meticulously examined the weapon. The barrel radiated such intense heat that the air around it visibly shimmered. He carefully ran his fingers over the receiver, searching for any telltale signs of stress, such as cracks, bulges, or deformations. "Nothing," he declared, a quiet satisfaction in his tone. He then proceeded to disassemble the bolt mechanism, revealing no signs of distortion. Crucially, the locking lugs, critical for containing the immense pressures, displayed no damage whatsoever. "It worked," Green stated softly, a profound sense of accomplishment evident in his voice. The manufacturing tolerances held true. Over the ensuing 3 weeks, Dr. Green subjected 6 prototype M2 machine guns to an increasingly brutal and comprehensive battery of tests. These trials included the continuous firing of 50,000 rounds, barrel replacements mandated every 5,000 rounds, and the repeated firing of proof loads every 500 rounds. Further extreme conditions involved immersion in sand, mud, and corrosive salt water, followed by immediate firing, freezing the weapons solid before discharge without any prior cleaning, and even deliberately using worn barrels, damaged parts, and misaligned components. The resulting performance data was nothing short of extraordinary, painting a stark contrast between the old and new designs. The M1921 Browning, the preceding model, exhibited an average of merely 840 rounds before its first malfunction, suffered 12.3 malfunctions per 1,000 rounds, required armorer adjustments after every single barrel change, R100%, and achieved a field reliability rating of a mere 68%. In stark opposition, Green's redesigned M2 Browning boasted an astonishing average of 42,320 rounds before its first malfunction, experienced only 2.1 malfunctions per 1,000 rounds, necessitated 0 armorer adjustments per barrel change percent, and achieved an exceptional field reliability rating of 94%. Armed with these compelling results, Green promptly submitted his comprehensive report to Army Ordnance, accompanied by a strong recommendation for the M2's immediate approval for production. On April 8, 1932, in Washington, D.C., the Army Ordnance Board convened a critical meeting. 12 senior military officers and distinguished civilian weapons experts had assembled to scrutinize Dr. Green's M2 proposal. While they had reviewed his extensive test data, a palpable skepticism permeated the room. Colonel Frederick Rice, the chief weapons procurement officer, initiated the interrogation. He acknowledged the impressive nature of Dr. Green's test results, but immediately highlighted their unprecedented character, noting that no machine gun had ever before attained a 94% reliability rating under realistic field conditions. Green countered by asserting that no machine gun had ever been manufactured to such meticulously tight tolerances. Rice seized upon this point, arguing that such exacting design specifications presented an insurmountable challenge for mass production. He contended that what functioned flawlessly for 6 meticulously hand-built prototypes would prove utterly unfeasible for 50,000 production-line weapons. Green responded that he had, in fact, developed detailed manufacturing specifications. However, Rice remained unconvinced, predicting that most contractors would be unable to meet these rigorous standards. And even if they could, the production costs would be prohibitive, making the M2 twice as expensive to produce as the existing M921. Major General Williams then interjected, raising additional concerns regarding Green's proof testing methodology, specifically the use of ammunition loaded 30% over pressure. He deemed this an unconventional procedure, stating that some of his staff believed the testing was unnecessarily perilous and in clear violation of established safety protocols. Green maintained that the aggressive testing had definitively proven the design's inherent robustness. General Williams, however, retorted that it might equally have demonstrated Green's recklessness. He then challenged Green, very authority, pointing out that he was primarily a manufacturing engineer, not a weapons designer, and that his redesign represented a radical departure from John Browning's original concept. Williams provocatively questioned whether Green believed he possessed superior knowledge to the legendary John Browning himself. The room immediately erupted into a cacophony of arguments and conflicting opinions. Shouts of, "The test data is undeniable," clashed with, "Test data means nothing if we can't mass-produce the weapon." Other voices advocated for exploring 20mm cannons, while others stressed the millions the Army had already invested in 50-caliber development. Throughout this bureaucratic storm, Green stood silently, observing his painstaking work being dissected and challenged. Suddenly the room fell into an abrupt silence as General Douglas MacArthur made an unexpected entrance. As the Army Chief of Staff, MacArthur held the highest-ranking position in the U.S. Army, and his presence at this unscheduled meeting immediately commanded everyone's attention. MacArthur wasted no time, stating that he had not only reviewed Dr. Green's comprehensive test data, but had also examined casualty reports from recent field exercises, where M1921 machine guns had tragically failed during simulated combat scenarios. He declared unequivocally that the current weapon was, in effect, costing American lives due to its inherent unreliability, and Dr. Green's innovative design directly addressed and resolved this critical issue. Colonel Rice attempted to raise an objection about the manufacturing challenges, but MacArthur swiftly cut him off. "Will be overcome," he asserted with absolute authority. He then proceeded to authorize immediate production trials, stating that if existing contractors proved incapable of meeting Dr. Green's stringent tolerances, the Army would simply find new contractors who could. With finality, he declared, "The M2 is approved." A profound silence enveloped the room once more. MacArthur then turned his gaze directly to Dr. Green, instructing him, "Dr. Green, you'll oversee the production implementation personally. I expect the first production M2s delivered within 6 months." The affirmation, a simple "yes, sir," marked a pivotal juncture, a quiet acknowledgement of a development destined to irrevocably alter the landscape of aerial combat. Yet, the true crucible, the ultimate validation of this groundbreaking innovation, remained on the horizon, awaiting the fierce engagements poised to unfold across the embattled skies of Europe and the vast expanse of the Pacific. On the 15th day of December in 1933, a significant milestone was reached at the venerable Springfield Armory. The inaugural batch of M2 Browning machine guns meticulously progressed off the assembly line. A dedicated individual, identified as Green, personally undertook the rigorous inspection of the initial 100 units, scrutinizing every critical dimension with exacting precision. The manufacturing processes were demonstrably holding their demanding tolerances, a testament to meticulous engineering and craftsmanship. By the middle of 1934, the United States military commenced the methodical process of phasing out the older M1921s in favor of the newly introduced M2s. However, this transition proved to be a protracted endeavor. Thousands of the M1921 models were still actively deployed across various branches, and a considerable number of commanding officers expressed a natural reluctance to embrace an unproven weapon system, preferring the familiar reliability of established ordnance. The compelling evidence that would ultimately sway these cautious perspectives was, surprisingly, to emerge from an entirely unforeseen quarter. Then in July of 1937, the global stage witnessed the eruption of the Second Sino-Japanese War in China. A contingent of American volunteer aviators, who would later form the embryonic core of the legendary Flying Tigers, were among the first to receive aircraft outfitted with the cutting-edge M2 machine guns. Their subsequent dispatches back to the United States were unequivocally unanimous in their praise, hailing the M2 as nothing short of a revelation in military technology. Captain Claire Chenot, a prominent figure among these volunteers, articulated his profound assessment, declaring that the M2 Browning has fundamentally changed aerial combat. Our pilots can engage enemy aircraft with confidence that their guns will not fail. He further elaborated on its exceptional performance, noting, "In 63.3 confirmed aerial victories, we have experienced only 2 gun malfunctions, both from combat damage, not mechanical failure. The weapon is extraordinary." Despite this early resounding success, the true ultimate trial for this formidable weapon was yet to arrive, looming on the horizon of the impending global conflict, World War II. As we delve deeper into this fascinating history, we invite you to stay with us and watch the conclusion of this compelling video. We would be immensely grateful for your support in the form of a like and a subscription to our channel. Please also consider leaving a comment below, sharing where you are from and what your thoughts are on the critical topic of weapon reliability in historical conflicts. The morning of February 20th, 1942, witnessed a dramatic confrontation high above Java in the Netherlands East Indies. Lieutenant Garrett Shorty Whitaker, skillfully piloting a P-40 Warhawk, found himself embroiled in a fierce engagement against a numerically superior force of Japanese Zeros. His aircraft was powerfully equipped with 6 M2 Browning machine guns, 3 meticulously integrated into each wing. The Japanese fighters outnumbered the American contingent by a daunting 3-to-1 margin. Whitaker, displaying keen situational awareness, identified a Zero aggressively diving upon his wingman. With decisive precision, he executed a sharp bank, meticulously aligned his shot, and firmly engaged the trigger. All 6 M2s discharged their devastating payload in flawless, synchronized unison. The targeted Zero, unable to withstand the concentrated torrent of fire, disintegrated violently in midair. Another Zero swiftly initiated an attack from above. Whitaker, demonstrating exceptional piloting prowess, rolled his aircraft inverted, executed a precise pull-through maneuver, and expertly positioned himself onto the tail of his new aggressor. A subsequent, decisive burst from the M2s followed, tearing the wing from the Japanese Zero. Lieutenant Whitaker continued his relentless engagement for an astonishing 18 minutes, a duration considered an eternity within the frenetic confines of aerial combat. Throughout this grueling ordeal, he expended an impressive 2,400 rounds. Remarkably, not a single malfunction occurred, culminating in 3 confirmed enemy kills. He eventually returned to base with his ammunition bays completely depleted and his aircraft bearing the scars of battle. Yet every single one of his machine guns remained fully operational. His subsequent report to intelligence agencies contained a singular, impactful statement. "These 50 calibers are the only reason I'm alive." Following these initial combat reports, a torrent of comprehensive data began to inundate military analysts from every theater of operations. The M2 Browning's combat performance between 1942 and 1945 was meticulously documented. A staggering total of over 2 billion rounds were expended in combat engagements. EO. The average malfunction rate was an exceptionally low 1.8 per 10,000 rounds fired. Furthermore, only 4.2% of the guns required replacement due to wear annually, culminating in an impressive field reliability rating of 96.3%. This remarkable performance stood in stark contrast to the M1921 Browning's combat record from 1927 to 1941, which exhibited an average malfunction rate of 11.4 per 10,000 rounds, an annual replacement rate of 23% due to wear, and a significantly lower field reliability rating of 71%. The profound improvement in the M2's reliability directly translated into an undeniable increase in pilot survival rates and overall operational effectiveness. On June 13, 1944, amidst the intense aerial battles raging over Normandy, France, Captain Robert Johnson, at the controls of a P-47 Thunderbolt, found himself in a desperate confrontation against a formidable force of 25 German fighters. His aircraft sustained repeated devastating hits. Cannon shells mercilessly tore through the fuselage, shredded sections of the wings, and utterly destroyed the canopy. Johnson himself was wounded, and his Thunderbolt was rendered barely flyable. Yet his formidable array of 8 M2 Brownings continued to unleash their fire without falter. In a desperate, running battle back towards the safety of England, he managed to shoot down 3 German fighters. Upon his eventual harrowing crash landing at his home base, armament officers meticulously counted 225 distinct holes, riddling his aircraft. The M2s had expended an astounding 4,800 rounds, suffering only a single malfunction, a damaged ammunition feed, which was directly attributable to a 20-millimeter cannon hit, not an inherent mechanical failure. Captain Johnson's survival was unequivocally attributed to the unwavering performance of his weapon systems. Such compelling narratives rapidly proliferated across all fronts. In the Pacific Theater, Marine Corps Wildcats and Corsairs, each heavily armed with M2s, systematically established aerial dominance over Japanese aircraft. The kill ratio decisively shifted in favor of American pilots, a testament not only to superior tactics and rigorous training, but, significantly, to the M2's unparalleled and unyielding reliability. From the perspective of the German Luftwaffe, post-war interrogations of captured pilots offered invaluable insights into their adversaries' weaponry. Major Hans Eckehard Bob, a highly decorated German ace credited with 60 aerial victories, was questioned by Allied intelligence. He candidly remarked, "The American 50 caliber was devastating, not because each gun was more powerful than our 20mm cannon. It wasn't. but because American fighters carried 6 or 8 guns, and all of them worked every time. When you engaged an American fighter, you knew you would face coordinated fire from multiple weapons. There was no lucky jam to give you an opening. Our MG-151 cannons were powerful, but they jammed frequently. The American guns never did. Johannes Steinhoff, another distinguished German ace, corroborated this sentiment, adding, "We feared the P-51 and P-47, not just for their performance, but for their firepower." The .50 caliber Browning was the most reliable aerial weapon of the war. When Americans opened fire, you knew every gun would fire until they ran out of ammunition. Against such reliability, even superior tactics couldn't always save you. The unassailable data further underscored this narrative. A comprehensive combat effectiveness comparison between 1943 and 1945 revealed stark differences. American fighters, equipped with M2 Brownings, required an average of 1,800 rounds per aerial victory. Their gun malfunction rate, leading to mission aborts, was a mere 0.7%, and pilot confidence in their weapon systems soared at an impressive 94%. In contrast, German fighters armed with MG-151 20 cannons required an average of 870 rounds per air victory, seemingly more efficient per shot. However, their gun malfunction rate causing mission aborts stood at a significant 8.2%, and pilot confidence in their weapons lagged at 73%. While the German cannons possessed greater individual destructive power per projectile, the M2's consistent and unwavering reliability ensured that American pilots could effectively and consistently bring their superior volume of firepower to bear in every engagement. In August of 1945, during the critical B-29 operations over Japan, each B-29 Superfortress was defensively armed with up to 12 M2 Brownings. These formidable heavy bombers conducted high-altitude bombing missions, where their defensive guns were required to operate flawlessly in extreme conditions, enduring temperatures plummeting to minus 40 degrees Celsius at altitudes where the atmospheric air density was too thin to sustain human life without the aid of oxygen masks. Despite these incredibly harsh environmental challenges, the M2s performed with unwavering perfection. Gunnery Sergeant Michael McGuire, who served as a tail gunner aboard the B-29, City of Los Angeles, discharged an astonishing 18,000 rounds over the course of 35 combat missions. His guns experienced only 2 malfunctions, both instances attributed to frozen condensation that quickly cleared after a few initial rounds were fired. "I trusted those .50s with my life," McGuire later recounted with profound conviction. "When Japanese fighters came at us, I knew my guns would fire." That confidence, that absolute certainty that your weapon won't let you down, that's precisely what preserved my sanity through 35 harrowing missions over Japan. According to meticulous military assessments, the significantly enhanced dependability of the M2 machine gun prevented the loss of approximately 2,800 aerial vehicles that would otherwise have been destroyed due to failures in their defensive armaments. Furthermore, a staggering 18,600 lives belonging to aircrew members aboard bombers were preserved, as these formidable machines were able to mount successful defenses against enemy incursions. An additional 4,200 fighter pilots emerged victorious from their aerial skirmishes, their survival directly attributable to the flawless operation of their weaponry. The groundbreaking manufacturing advancements championed by Samuel Green, coupled with his extraordinary readiness to validate these improvements through perilously dangerous, even suicidal, testing methodologies, ultimately safeguarded the existence of more than 25,000 American personnel. This monumental achievement underscores the profound impact one individual's unwavering dedication to exacting precision in manufacturing could have, directly leading to the preservation of tens of thousands of lives. As May 8, 1945 dawned, marking the joyous occasion of Victory in Europe Day, Samuel Green found himself at the Springfield Armory, observing newsreel projections depicting jubilant American forces commemorating the triumph across the European continent. The flickering images revealed soldiers discharging M2 Browning machine guns in a spontaneous burst of celebratory gunfire. These very weapons, intrinsically linked to his meticulous work, had undeniably played a pivotal role in securing the Allied victory. Yet beyond the confines of Springfield Armory, his name remained utterly unknown to the broader public. History justly lionizes John Browning as the brilliant mind behind the M2's initial conception, while General MacArthur garners recognition for green-lighting its mass production. Legendary aerial combatants, such as the Aces Bong and McGuire, are rightly lauded for their astounding battlefield successes. In stark contrast, Samuel Green, the dedicated manufacturing engineer whose tireless efforts transformed the M2 from a design concept into a fully functional, reliable weapon, has largely faded into obscurity, a fate he remarkably seemed to accept without complaint. Indeed, when approached by a journalist from the local Springfield newspaper, seeking an interview about his crucial contribution to the M2's development, Green humbly demurred, stating, "John Browning was the visionary who designed the firearm. My role was merely to render it producible. That hardly constitutes a compelling narrative. Please stay with us and watch the end of the video. We will be grateful for your like and subscription. We invite you to share a comment about where you are from and what you think about the video topic." Upon the cessation of hostilities, the quantitative output data for the M2 machine gun presented truly astonishing figures. More than 2,000 units of the M2 were manufactured, while the cumulative number of rounds expended in active combat operations ascended to an astounding 2.3 billion. Remarkably, its operational tenure persists uninterrupted, with the weapon remaining in front-line deployment for over 8 decades, subsequent to its initial introduction. Military forces in more than 100 nations across the globe continue to incorporate M2s into their arsenals, solidifying its distinction as the longest-serving military armament in the annals of American history. The fundamental architectural blueprint, meticulously refined and finalized by Green in 1933, endures as a cornerstone of contemporary frontline military equipment. While contemporary M2A1 iterations integrate advancements in material science and refined production methodologies, the essential design paradigm, notably encompassing Green's exquisitely engineered, precision-manufactured timing mechanism, has retained its original unaltered integrity. In the present day, every constituent branch of the United States military apparatus deploys the formidable M2 Browning machine gun. These robust weapons are routinely affixed to a diverse array of platforms, including armored Humvees, naval vessels, various aircraft, and static ground emplacements. Elite special operations units frequently incorporate them into their operational gear. Navy SEAL teams strategically position them on their maritime craft, and the United States Marine Corps depends heavily on their consistent performance. Across the challenging operational theaters of Afghanistan and Iraq, M2s discharged millions of projectiles, consistently exhibiting the same fabled dependability that Green meticulously engineered 9 decades prior. The extraordinary enduring operational life of this weapon unequivocally validates Green's foundational tenet that rigorously controlled manufacturing tolerances inherently negate the necessity for frequent field adjustments. While contemporary manufacturing processes are capable of achieving far more stringent tolerances than those attainable during Green's era, the underlying engineering principle he championed retains its immutable validity. Samuel Green concluded his distinguished career at Springfield Armory in 1953 at the age of 62. His commendation comprised the Army's Meritorious Civilian Service Award, a formal certificate, and a simple handshake, a recognition devoid of any public ceremony or media attention. Green passed away in 1968 at 77 years old. His local Springfield newspaper obituary merely noted his profession as an engineer at Springfield Armory, conspicuously omitting any reference to his pivotal role with the M2. Nevertheless, in 1973, a contingent of World War II veterans, having discovered Green's indispensable contribution to the M2's development, sought out his widow, Evelyn, and bestowed upon her a commemorative plaque. The deeply moving inscription on the plaque declared, "To Samuel Green, whose precision saved our lives. Because of your work, our guns never failed us. Because of you, we came home. The crews of the 8th Air Force will never forget." Evelyn Green was overcome with emotion upon reading these words, tearfully reflecting, "Sam would have simply stated he was merely fulfilling his duty, but I truly believe he would have felt immense pride." The profound takeaway from this narrative is that the most impactful innovations do not invariably manifest as revolutionary conceptual overhauls, but rather frequently emerge as subtle, yet critical advancements in manufacturing exactitude. Often the true hero is not the widely celebrated inventor, but rather the diligent engineer whose expertise transforms a theoretical invention into a fully functional reality. Samuel Green unequivocally demonstrated that unparalleled excellence in the practical execution of a design holds equivalent significance to the initial conceptual brilliance. His extraordinary commitment to rigorously testing his work, even to the point of deliberate destruction, and literally jeopardizing his own life to validate the absolute precision of his manufacturing techniques, ultimately preserved the lives of 25,000 Americans. Therefore, on any future occasion, when the legendary Browning M2, often heralded as the gun that won the war, is discussed, it is imperative to recall Samuel Green, the manufacturing engineer whose genius ensured its unfailing jam-proof operation.